Good afternoon. My name is Mongsa Jaimok Damawaro of 8th grade, Mahabodhi School, Mysore, from Tripura. My hobbies are to read novel, play football, and do drawings. Now I am going to present a short note on Indian Institute of Space Science and Technology. Asia's first space university was established in Thiruvananthapuram in 2007 with the objective of offering high quality education in space science and technology to meet the demands of India in space program. The institute offers undergraduate, postgraduate, doctoral and programs in broad areas of space science and technology applications. The institute is committed to excellence, the teaching, learning and research. IIST fosters state-of-art research and development in space studies and provides a think tank to explore new directions for the Indian space program. The institute has...
Let it be faster, he's reading, yeah.
Yes, sir. The institute...
You have done it.
The institute has faculty strength of nearly 100 spread across 7 departments. IIST is a residential institution located at Viliamala, approximately 200 kilometers from Thiruvananthapuram city. This was a short information about IIST, and now I'm going to share my experience, what I have learned in 10 weeks. Firstly, it's about the UNEP APPEL, United Nations Environment Program. I used to be very fond of gardening, and so I used to think about lots of environment. We have to clean the environment whenever it is dirty. We have to say no to the plastics and use cloth bags instead of using plastics, because it's very harmful to environment. So next, I was also very good in drawings, so I came up with another week 2, spiritual and mindfulness. We should always follow Panchashil and have spiritual in your life and mindfulness at the same time. If you are mindful, there will be no harm and no problems. Instead, there will be harmony in society. So I want to thank PSF, People Science Forum, which was dedicated in the name of Venerable Acharya Buddharakita Banteji. I'm very grateful to them for encouraging us very nicely and dedicatedly. Thank you very much. And finally, I want to thank Mr. Professor Jagannath Venkataramaya sir for encouraging us with his dedicated mind, and we are very proud to have such a kind person in our lives. There is a quote given by Buddha: all know the path, but all know the way, but very few walk on it. Our Acharya Buddharakita Bante had shown the path, and we should walk on it instead of ignoring it. We have to work on it so that we can achieve our goal. So thank you very much for listening me so patiently. Thank you all.
So good afternoon, one and all. So myself Ashutosh Koni of class 8, studying at Mahabodhi School, Mysore. So I am from Bidar, Karnataka. So before starting my presentation, I have a question. Space is for everybody. It's not just for a few people in science or math, or for a few select group of astronauts. That's our new frontier out there. And it's everybody's business to know about space. By Christian McCullough. So I'll start my presentation. It's about people, science and technology. So the advantages of people, science and technology. People's science and technology makes our life easier. It helps us organize our daily activities. Due to this, our works can be done faster. It also helps us in communication with each other in faraway place. This helps us to better know and understand other cultures and societies. And it also reduces our transportation time. Through science and technology, it is easier for inhabitants to communicate with other people around the globe. It is also significant in the field of business because the transactions and other events are done through the computer. Science and technology enables every people to live in an easy and modern way of life. So this was about people, science and technology, and this slide shows this space situational awareness. This was the week 1 of our 10 free virtual orientation program. I was very interested in SSA, and it tells about space situational awareness and how it began. And another topic which I was very much interested was counter space weapons. So I learned in this that how people or this organization sends missiles from the ground station to the space for destroying near Earth objects which may be harmful to satellites or Earth. So this was all done by People's Science and Forum in the memorial of Dr. Acharya Buddha Rakita. And I thank Jagannath sir for this organization. And thank you everyone, all the panelists for hearing me.
Now next.
Yes, sir. I'm from Northeast, but I'm
Okay.
studying in Mahabodhi School, Karnataka, Mysuru.
Great.
And my
Great.
hobbies are
Go ahead.
playing cricket, reading novels, and exploring new things. Now I would like to
Gaurang,
give a short
little
introduction.
little louder.
I would like to give short introduction about remote sensing satellite.
Good.
Remote sensing satellite is the acquiring of information from a distance. Example, like NASA observes Earth and other planetary bodies through remote sensors on satellites and aircraft that detect and record reflected and emitted energy. And some of the applications of satellite imagery and remote sensing data, this provides a base map of graphical reference and assisting planners and engineers. And it extracts mineral deposit with remote sensing based spectral analysis and disaster mitigation, planning and recovery, and also help in agricultural development. And some of the geological applications are remote sensing can help map large and remote areas. We can see the remote areas in a large way through the remote sensing satellites. This makes it possible for geologists to classify an area where the rock type and study about the geography, and they can track the changes caused due to the natural disaster and other. And it also helps in the land use planning, those studying land development, and can apply remote sensing to study about the land and development. They can make changes in the land, and also about geographic information system mapping GIS. Remote sensing images are used as the input data for raster based digital elevation model or DEMS. What I have experienced in 10-day free orientation program are many, but I would like to explain two. First one is counter space, second is near Earth object. This is one of my work that I have done in this 10 week. It is the 5th week out of 10. It is about counter space, which deals with the asset weapons and that weapon, and between the like fighting, or you can say battle. But this can also stop some of the asteroids that instead of uh, this instead of this space weapons between the satellites and all, we can use this in this like asteroids, where we can like destroy the asteroids coming through the earth. And even the moon, we can say it is like a nearer object. Not all the nearer objects are harmful. Like you can see the moon, and this is all the moon is also useful. We can't say all the nearer objects are harmful. So I would like to thank all the panelists here, and I would like to thank specially to Jagannath sir and everyone. Thank you.
Okay. Thank you very much. Now next. Very good.
Good afternoon to one and all. Myself, Tanzan Othal, studying in 8th grade of Mahabodhi School, Mysore. My hometown is from Ladakh, North India. So today, I would like to present my topic as planetary defense. So, as you all know that our beautiful Earth is surrounded by many dwarf and other rocks or meteorites. So before giving explanation, I would like to tell you all about the definition of planetary defense. Planetary defense entails detecting, monitoring, understanding, and mitigating near-Earth objects, also known as NEOs. And they are small objects in our solar system like asteroids and comets that come close to the Earth. And these small objects come near to this Earth because of the gravitational pull of this Earth, and it pulls those asteroids towards them. And whether or not an object is classified as NEOS depends on its orbit, size, and composition. So I would like to show you with a small photo images. So in this you could see that this asteroid is traveling toward the Earth at a rapid speed. So this is detected or sensed by a satellite and sent a message to the Earth, and from there a missile is launched in order to stop the journey of this asteroid towards the Earth, and it destroys these asteroids. Millions of years ago, as we all know that there used to be dinosaurs and other living organism. This all was also, they all are not here because of the asteroids. Millions of years ago, there was a huge fall of asteroids, meteorites, and comets. At that time, there wasn't any planetary defense, so they all were dead, and all lead to death. Some of you get any inspiration, and if you think that in your life you would like to choose your ambition as planetary defense, then how to become a planetary protection officer? Applicant must have advanced degree in science or maths and experience planning, executing, or overseeing the elements of the space program of the national significance according to the job description. NASA will be accepting the applicant for the new planetary protection officer through August. And this is one of my work of the fourth week, that is disaster risk reduction. In this, you could see that when there is a plant or there is a more tree, in that time you will be easy, and when the flood comes, it is easily absorbed by the trees, and there couldn't be any sorts of destruction in the neighboring area. But when the people cut the trees, and it leads to deforestation, and the flood comes at a rapid speed and cause a destruction. In a second, you could see that the people outtakes the ground level water, and it takes, when this ground level depletes or when it's come down, at that time the living species and all the crops it dies out. And the disaster is only not caused by the nature, it's caused by the human being. As you can see, the people also try to save their time and to make a tunnel in the mountain. But as we make a tunnel, it changes the weight of the mountain, and as some part of the mountain it falls and some get affected by this. So I would like to thank People Science Forum is dedicated to Venerable Dr. Acharya Buddharakita Memorial Non-Formal Space Situational Awareness Campaign 2021. At last, I would like to give my word of thanks to all the panelists and all the scientists who are listening to my this presentation very attentively. And I would like to also thank Mr. Jagannath sir for guiding us and giving us this opportunity to share our knowledge to all of them. Thank you, sir.
Are you, is this
Yeah, perfect.
well?
Perfect. Please go ahead.
So a warm afternoon to all the panelists and all the participants present over here. So first of all, my name is Sujal Muniwaro. I'm studying in 7th standard at Mahabodhi School, and I'm from Tripura. And my hobbies are playing football and drawing and many more. So now I would like to share my short information about space science and technology. So space technology is technology for use in travel or activities beyond Earth's atmosphere for purposes such as space flight or space exploration of the sciences. Astronomy and earth science benefit from space technology. So space science encompasses all of the scientific disciplines involve space exploration and study natural phenomena and physical bodies occurring in outer space, such as space medicine and astrobiology. The beneficial uses of outer space, including strengthening communication infrastructure, disaster management, and education, agriculture, environmental protection, and natural resource. These are some of the application of space science. And the uses of space science and technology could be of benefit in various areas such as aviation, maritime and land transportation, urbanization, mapping and surveying, human health, disaster management, and many more. So this was my some information about space science. Now I would like to tell my experience about what I have learned in these 10 weeks. So these two topics which you can see is disaster risk reduction and near Earth object are two topics of 2 weeks which I have chosen. So in the week 4, this disaster risk reduction, I have written a note on it. So how we can reduce the disaster caused by natural disaster like floods, tsunami, volcano, earthquake. So I've written some techniques or tips which we can reduce disaster. So and this is the week 2 project, that is near our object. I have written a drawing. So the asteroid, I have drawn asteroid. So lastly, I would like to thank all the panelists for listening to me, and I would like to thank PSF for giving us this opportunity to present here and attend this conference. And mostly I would like to thank Jagannath sir for your guidance, and thank you everyone for listening to me.
A very warm good morning, good afternoon to everyone. My name is Arjun Kam and I'm studying in 9th standard in Mahabodhi School, and my hobbies are playing football and read novels and exploring, and I am from Arunachal Pradesh. And today I am very fortunate to have such a good opportunity
contract with each and every one of you. And I would like to welcome you in this first National Virtuous Conference on Space Science Technology for school students. And today I'm going to speak about the interplanetary exploration by ISRO. First of all, interplanetary exploration is the missions explore the planets, comets, and the other objects of our solar system, as well as the characteristic of the interplanetary medium that lies between them. There have been many such missions, several stands out, and I am very proud to say that our country, India, has an interplanetary exploration called ISRO, and ISRO have also conducted many missions like Chandrayaan, Mangalyaan, and many others, and I would like to speak briefly about some of the missions carried out by ISRO. First one is Chandrayaan program. Chandrayaan 1 was started in 22 October 2008 and it has ended in 28 August 2009, and Chandrayaan 1 was the first Indian lunar probe. It was launched by the Indian Space Research Organization on 22 October 2008 and operated until August 2009, and this mission included a lunar orbit and an impactor. And the second one is Chandrayaan 2. It was started in 22 July 2019, and orbital functions. The lander crashed out on moon's surface due to the loss of control during the final phase of descent, and it has ended. Chandrayaan 2 was launched from the second launch pad at Satish Dhawan Space Center on 22 July 2019 at 2:43 p.m. first, and to the moon by a geosynchronous satellites launched vehicles Mark III, and the plane orbit has an perigee of 169.7 kilometer and an apogee of 45,475 kilometer, and it consists of a lunar orbiter, lander, and rover, all development in India. The main specific objective is to map the location and abundance of our lunar water. Interplanetary missions named Mars Orbiter Mission, which is also called as Mangalyaan, and started at 5th October 2013 and ended at ongoing. Still it's going on, and Mars Orbit Missions MOM, and also called as Mangalyaan, is in spacecraft orbiting Mars since 24 September 2014, and it was launched on 5th November 2013 by the Indian Space Research Organization ISRO. It is the first interplanetary missions, and ISRO has become the fourth space agency to reach Mars. And the last one is AstroSat. It was started at 28 September 2015 and ended at ongoing. It's still going on, and AstroSat is the first dedicated Indian astronomy satellite mission launched by ISRO on 28 September 2015, and which enable multiple wavelength observation of the celestial bodies and cosmic source in X-ray and UV spectral bands simultaneously. This scientific payloads covers the visible, soft, and hard X-ray regimes. The uniqueness of AstroSat lies in its wide spectral coverage extending over visible UV, soft, and hard X-ray regions. And now I would like to show some of my work on the Oriental program, which was conducted in the in our beloved Venerable Acharya Buddha Rakhita Bantiji. And here you can see some of my poster of International Space Station. From my vision, this is the place where the astronaut works and experiments are also conducted here. And this is my another vision on individual space situation awareness. Here you can see this is my work on space situational awareness. And lastly, I would like to thank PSF, People Science Movement, and Professor Jagannath sir for organizing, giving us this opportunity. And lastly, I would like to thank all the wonderful scientists for organizing this program. Thank you all for your kind attention, and have a nice day. Thank you.
Thanks to the coordinators for such an exciting opportunity, and thanks to Kuti sir for selecting us as a part of UL Space Club to present these topics in such an occasion. Thanks for this opportunity again. Today I am going to speak about some aspects of rocket dynamics. Myself, I am Varun. I am a student fellow leader of UL Space Club. I'm working with UL Space Club for the last few years, and I'm a BTech student from NSS College of Engineering, Palakkad, first year BTech student. Some aspects of rocket dynamics. I don't want to cover all the technical details of rocket dynamics. I just want to compress all technical details, and I just want to mention only few ideas regarding rocketry. I have try to simplify my presentation as much as possible so that the younger one can also understand what I'm saying. The youngest one can also understand what I'm saying about rockets. So let me move on to my presentation. So first of all, when we are talking about rocketry, the basic things when we are reading a book about rocketry, or when we are watching a website of rocketry, the basic thing that they are giving is Newton's third law of motion. Newton's third law of motion is very much important in rocketry. Like it is a basic principle of rocketry that every action has an equal and opposite reaction. A simple experiment that can be shown to a 6-year-old boy is we can fill a balloon, and when we release the mouth of that balloon, the air will move out of the balloon, and balloon will move to the opposite direction of that air. So this is a basic example of Newton's third law of motion. Like this, the fuel is burned and the thrust is going out downwards, and the rocket is moving upwards. This is a basic principle of rocket. And when we are talking about rocketry, I just want to mention about two legends. I just want to tell the names. There are many people who have worked for improving rocketry and improving the propulsion systems, but I just want to mention only two as the important two amongst them. So first, to explore the mathematically ratios of energy and thrust by weight of various fuels in rockets, it was Robert H. Goddard. He is considered as a father of modern rocketry, and because he was the first one to invent a liquid engine rocket. He is the inventor of a liquid engine rocket, and he was the first one to do so. And another one, you may know him by his photo. That's why I didn't add his name. I just want to tell that because he is Werner von Braun. He was a part of Nazi Germany. He was a supporter of Nazi Germany in Second World War. But he's not known about as supporting as a Nazi Germany, but he's known for V2 rockets. His V2 rockets were very famous at that time, and at this time also, because it was very much developed, and it is a world famous one. The next photo I have given is that of V2 rocket, and V2 rocket have been created again. Just model, the exact model of V2 rocket has been created again, and it is stored in the museums of Germany. We can see a lot of photos and videos regarding that V2 rocket models in YouTube and website. So rockets for space exploration. Rockets are used in war. Actually, like I said about Werner Braun and also Tipu Sultan. We are so proud that our Dr. Kalam so the painting of Tipu Sultan at NASA that he used rockets in wars. So like that, rockets were used for wars, and now it's commonly used for space exploration. Mainly, there are two type of rockets used in space exploration. One is SLVs, that is satellite launching vehicles, and another one is sounding rockets. Satellite launching vehicles are very much known to all of you, and sounding rockets are not that much famous. And sounding rockets are launched from Tumba as a part of ISRO. There's an institution called TERS, Tumba Equatorial Rocket Launching Station. It was established by Vikram Sarabhai, and our Dr. Kalam and many other prominent scientists were part of TERS for many years, and they worked there. And India launched the first sounding rocket, which was bought from USA, Nike Apache from Tumba. And now also there's, as of my knowledge, there's a launching of a sounding rocket is happening every month. And sounding rockets are used for studying the upper atmospheric regions and space research, probing that type of regions, and to study about the ions in the ionosphere. That's why it is located at Tumba, because Tumba is so close to the geomagnetic equator of Earth. So that's why Tumba is selected to start TERS for sounding rocket. And the next one is about satellite launching vehicles. Before going to the topic mentioned in this slide, just want to give an intro about satellite launching vehicles. I saw that one of our panelists, one of our great scientists, as mentioned in the chat window in the when the last presentation was going on, satellites are rockets are parents, and satellites are children. That satellite launching vehicles put them into the orbit. That's why it is called satellite launching vehicles. And it is very much important to each and every space science aspirant, space technology aspirant. So mainly, the two engines are used in satellite launching vehicles: solid engines and liquid engines. Liquid fuels consist of a fuel and oxidizer, oxygen, to for the burning of fuel in liquid engine. It is stored in two chambers in liquid engine: fuel in a separate chamber and oxidizer in a separate chamber. This is the method used in liquid engine, and there will be an ignition chamber other than these two chambers, and this fuel and oxidizer will be passed to the ignition chamber for the burning, and they will give some spark for the burning, and after the burning in the ignition chamber, the fuel will be out through the nozzle of rocket. This is the method used in liquid engine of a rocket. But when we are talking about solid engines, solid rocket consists of fuel and oxidizer as mixed, and it can be controlled at a stage that cannot be regulated, turned off. That's what I meant about solid rocket. But I saw that when reading many online articles, I saw that solid engines can produce much more thrust. And I just want to introduce two terms that we commonly use. Most of the students, even the young students, also uses these two terms, but they don't know what the actual meaning of these two terms: specific impulse and thrust. What is specific impulse? The thrust produced per unit rate of consumption of the propellant. Thrust is the amount to push a rocket engines provides a rocket. Like that, thrust. This is the definition of specific impulse and thrust, and these two terms are very much close to rocketry and very important when you are studying about rocketry. There will be a lot of problems when you are doing courses regarding rocket propulsion. I was doing a course with NPTEL by Madras IIT, and I was used to face so much questions regarding specific impulse and calculating the thrust of a rocket. And here is a small video to visualize how the liquid engine in a rocket works. Oxidizer is coming from one chamber and fuel is coming from one chamber, and it is passed to the ignition chamber, and we are giving an arc or spark to ignite the fuel. You can see that, and it will the fire will be there, and it will pass through the new nozzle to help the rocket to move forward. I just try to include a few rockets, images of few modern rockets in the order of size, but I know that this image is not much clear. Sorry for that. So sorry for that. It was an error with my presentation. But you can see today the strength of rockets are very much increased. We can see most of the students will be a fan of SpaceX, Starship, like etc. And I would like to directly move on to GSLV Mark III, which is India's most powerful rocket, which is known as the Bahubali of ISRO or Fat Boy of ISRO. Here it is a 3-staged rocket, and which is weigh for 640 tons. And there'll be 3 stages like S200 boosters, L110 stage, and a cryogenic stage. And that's the structure of GSLV Mark III, and it is used in our launch of our heavy satellites, and of course in our Chandrayaan-2 launch and a few other upcoming launches also. So thank you. I know that I didn't cover many areas regarding rocketry and many technical details regarding rocketry, but I just only want to mention the basic aspects of rocketry, a few basic terms. So that's why I concluded my slide in a simplified way. So if something error happened with me, please apologize. I apologize to all of you for that error. So thank you. You can contact me. Students can contact me if there is any help is needed. varunk.vadagar@gmail.com. That's my mail address. Thank you, sir. Thanks again. And I'm a subscriber of ISIE YouTube channel, and I watch most of the webinars they telecast through the YouTube channels. So thanks to ISIE for such an opportunity, and special thanks to AC Mathusa and VK Jain sir for such a nice opportunity for students like me. Thank you, sir.
Today, we are discussing about the first observational basis for the theory of expanding universe. The first observational basis is given by Edwin Hubble, but actually, a decade before Hubble's observation, some scientists, some physicists, along with some mathematicians, established a consistent theory for the expanding universe. But due to the lack of technology, there was no sufficient observational evidences. So through this presentation, let us check how Hubble came out with this observational basis. Hubble measured the distance of these astronomical objects and also the velocities with which they are moving away from each other, and compared these results, and he proposed a law known as Hubble's law. First of all, let's check out how he calculated these astronomical distances. He mainly used the standard candles to find out these astronomical distances. Standard candles are objects with non-brightness. Commonly, observers use inverse square law, which says luminosity of an object is inversely proportional to square of their distance to calculate their distances. And there are so many standard candles out there. Some of them are Cepheid variable stars and supernovas and also quasars. Hubble mainly used the Cepheid variable stars to calculate these astronomical distances. Let's check out what is Cepheid variable stars. Cepheid variable stars is a special kind of pulsating stars. Pulsating stars are stars which causes stellar pulsations, and because of these stellar pulsations, these stars expand and contract their outer layers, and as a result, their their stellar radius fluctuates, and this changes its luminosity. So first, we will find the distance to a nearest Cepheid variable star using parallax method. And from this distance and from their observed apparent magnitudes, we will find out their absolute magnitude and luminosities. Here, the luminosity is a measure of total energy radiated by an astronomical object, and absolute magnitude is simply the luminosity itself, and the apparent magnitudes are the amount of energy that reaching the Earth after traveling through the stellar medium. When a wave travels through the stellar medium, some of its components get extincted due to the stellar absorption, and only few of them reach the Earth. So this energy is known as apparent magnitude. And when we compared these luminosities of Cepheid variable stars with their time period, we found that the absolute magnitude of Cepheid variable stars are directly proportional with their long periods. From these results, we made a relation which connects absolute magnitude, apparent magnitude, and their astronomical distances, which is known as m equal to m plus phi minus phi log r. Here the capital M is absolute magnitude and small m is apparent magnitude, and r is their astronomical distance. Then after this, we will apply this exact relation to a distant Cepheid variable star which is situating at some other galaxies to measure the distance towards that galaxies. And we observe the period of that distant sample, and from those period, we can find out the absolute magnitude of that Cepheid variable star, and we can observe the apparent magnitude from the Earth itself. And using these two quantities, we can find out how far is that Cepheid variable star situated. And this is how Hubble calculated his astronomical distances. And then he thought, this is a picture of non-Cepheid variable star, which is situated in a Milky Way galaxy. And okay, then Hubble thought, if the as the theory says, if the universe is expanding, then all the objects move velocities. He tried to calculate these velocities. We know velocity is a vector quantity, so we can resolve these velocity into two components. One component which is parallel to the line of sight, and the another one which line of sight can be calculated using Doppler shift. Doppler shift is a method to find whether the source is moving away from us or whether it is moving towards us, using the variations in frequencies from the variations in frequencies of the wave. Hubble calculated velocities of these moving away objects using this Doppler shift, and he plotted all his observational data into a graph. And from this graph itself, it is clear that the velocity of these distant moving objects are directly proportional to the distance towards them. And from his data, he proposed a law which states that distant galaxies are rushing away from us with velocities which are proportional to their distances. And he also deduced a relation which connected the velocity of these distant galaxies to their distances, which is given here. V is equal to HR. V is the velocity of the velocity with which these galaxies are rushing away from us, and the R is the distance towards these galaxies. Here the H is proportionality constant, and it is known as Hubble's constant. This Hubble's constant have great significance, because when we take the inverse of the Hubble's law, 1 by h, and we try to find out its dimensions, we find that the dimensions of this Hubble's constant is exactly exactly the terms of time. So actually, by calculating the Hubble's constant, we are calculating the age of the universe, and we can this Hubble's constant. We can calculate this Hubble's constant from the graph itself. It is the slope of the graph, and this Hubble's law has one more greatest significance. That is, this Hubble's law is valid at every point in the universe. Every point in the universe. Every point in the universe. That is, this Hubble's law is valid at every galaxy and every point in the entire universe. And this is how Hubble came out with the first observational basis for the theory of expanding universe. That's all, and thank you for your kind attention.
Honorable Mathur sir, VK Jain sir, Kuti sir, other coordinators, and other respectable personalities, and my dear friends. I am very happy to be here with all of you to present my very small and simple presentation. Today, I am gonna speak about the history, present, future, and the applications of robotics in space science and technology. So let us start without any delay. Sorry, myself, Abhiram TP. As Kuti sir told, I'm 11th student like some of you, and I'm also a member of UL Space Club. As you can see, my presentation is titled as, yeah, we are also in space. Okay. As all of us know, robots are becoming as one of the unavoidable factor, even in the very slightest movement of Earth. So when I am saying a word robot, your mind may travel to so many images or videos or movies. It may consist of some giant robots like Transformers, Bumblebee, Optimus Prime, Prowl, etc. Robots like Valley, or just like Terminator. Actually, what is meant by a robot and what are the functions of a robot? When I googled, he told me that a machine resembling a human being and able to replicate certain human movements and functions automatically. Then these are the famous three laws of robotics by an American science fiction writer and biochemistry professor Isaac Asimov. The first law: a robot may not injure a human being or through inaction allow a human being to come to harm. The second one: a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. Then the third one: a robot must protect its own existence as long as its protection does not conflict with the first or second law. That means a robot doesn't have the right to resist the attack from a human. Okay. Okay. Let us conclude that a robot is a machine which obeys the commands of its owner and make the impossibles of human to possible and protect us from the tough situations. Robots or artificial intelligence is one of the most unexceptional things in the present world, as I told. Robots are used in very large number of technological and non-technological fields like medical field, engineering, agriculture, and transportation. AI is having a big role in even our country's security. When we check the history of robots, it take root from US and its apex is in the countries like Japan now. So it will be a Herculean task to do pass through the whole history of robotics. Then let us skip to the present. Here we go. In present, there are three main types of space robots that are explobots, helperbots, and at last automated system. Firstly, let us explore the details about explobots. Okay. As I listed, explobots or explorer robots are the most important robots in space science and technology. These explobots are very famous for their notable birds. As we know, this section is mainly includes rovers like Curiosity, Sojourner, Chang'e, our ISRO's partial failure Pragyan, and also our upcoming updated version of Pragyan in Chandrayaan 3. This type of robots can do as same as a human or more than humans. As we know, they are one of the first visitors in the planets like Mars, Moon, and Venus. At the time of interplanetary colonization or civilization, these explobots will be one of the most important factors. Then the next one, helperboats. As their name indicates, these are the robots which used for helping the crew in spacecraft. Just like explobots, helperboats is also an unexceptional factor in space exploration. In present time, so many helperboats are engaged in ISS for supporting their crew to produce better performance. They are in different size, structure, and also in different configuration. Then the automated systems. When you see this example image, you may think that is it a robot? Exactly. It is also considered as a robot because they are using only a very micro amount or a very small amount of human knowledge or human input. The subsystem related to heat shield and heat shield landing and the landing system related to the Falcon boosters are the most appropriate examples for automated systems. Because when you gave a subsystem related to heat shield or landing, you gave them the order to land, they will scan the terrain and they will map the craters, they will map the landing spot, and they will control the thrusters, landing legs, etc., and make the safe landing possible. This is the system which needs more care and more concentration for making it highly efficient. Well, I told about the category so far. Then what is happening now? What is the present condition of space robotics? When we speak about the present condition of space robotics, it's very bright. But still, we need more attention and we need more funding for nurturing the future. So many private companies are really interested in space robotics. So the issue of funding will be a very small issue or an abstract. Robotics, especially space robotics, is one of the technology branch which can lead us to the infinite canvas for the development of humanity with their supernatural ability. In the present time, we are using robots for so many uses like making a coffee, carrying a baby, or even for guarding purposes. As a trial run for the great future, we are using robots for not only simple tasks but also for very hard tasks. Let us check the details about the present condition of space robotics through some examples. Okay, the first and most famous one, Perseverance. As all of us know, this Perseverance is one of the rover or an exploreboat, which having heavy weight of the hopes of the people around the whole world. The major goal of Perseverance is to find the evidence or investigate about the chance of life in the red planet. This is a perfectly or efficiently engineered spacecraft or a rover. Actually, this is almost like our Curiosity, but in function, we have some difference. Unlike Curiosity, Perseverance can self-drive up to 200 meters per day. And he can also drill in the Martian soil and also collect the samples and let them for the further experiments. As we know, it also consists of the first single rotorcraft in another planet, not a single rotorcraft, a rotorcraft. The next one is a crazy little guy, IBM Simon. Simon is very famous for his structure and the configuration. This is also a masterpiece from IBM. IBM is the producers of the first computer, IBM ENIAC. Simon is one of the crew companion robot in ISS, just like our Astro Bees. It have a weight of 5 kilogram and have 32 centimeters of diameter. Simon stands for Crew Interactive Mobile Companion. He can freely fly, speak, sing, dance, and also assist the crew in their experiment. These all movements are based on 6 thrusters inside his body. The next one is an iconic phase of present space robotics, Canadarm2. As the name indicates, it's a robotic arm which made by CSA, Canadian Space Agency, for making the docking and retrieving of satellites for maintenance and after maintenance launching from ISS. In present world, Canada is really an unavoidable factor in space robotics and exploration. Maybe the updated version of Canadarm will be used in the upcoming Lunar Gateway mission led by NASA. And also, the influence of Canadarm in the step-by-step development of ISS and the fixing of Hubble telescope in its orbit is very big. I told about the present condition of space robotics and the categorization of robots so far. Well, what about the future? Is the future of space exploration is so far beyond our expectations or imagination. Then the space robotics is also waiting to do their duty to the great humanity. The future of space exploration is one of the most important factor like other categories. Let us check some upcoming missions for space robotics. The first and the most important one, Vyomamitra. I think some of you may heard about Vyomamitra. Yes, Vyomamitra is our dream project. Vyomamitra is a humanoid robot to support the crew inside our upcoming dream project Gaganyaan, and she will fly in the experimental flight of Gaganyaan. Gaganyaan will probably take off in 2022 at that time. Just like R2 of NASA, our Vyomamitra will brightly shine like a star above the skies of India. Then Dragonfly. Dragonfly is an upcoming mission by NASA. It's a multi-road craft to land on the largest moon of Saturn, Titan. Like Ingenuity, Dragonfly is a multi-cluster rotorcraft. NASA is going to make it possible with SpaceX. If it will become possible, it will be the first mission to fly or land on a planet beyond asteroid belt. Then the next one, Lemur. What a terrible name is it? Lemur. As we know, lemur is an animal like monkey. Actually, this lemur is limbed excursion mechanical utility robot, which is known as the mother of climb robot. It has 4 limbs, and its each limb is including 16 fish-hook fingers for making very hard grip. Actually, this project was stopped in 2019, but as I told, as a mother of climber boards, the AI of this robot will be adopted by some upcoming space robotics missions. Then the next one with with another terrible name, iceworm. Is it a worm like an inchworm or an earthworm? No. Iceworm is a little squiggly robot with only two lemur limb, which is developed for explore the moons of Saturn, Jupiter, and in future also Neptune and Uranus. Just like an inchworm, this is also moving with scrunching and unscrunching mechanism. This can also collect the samples from glaciers in addition of walking. As a son of lemur, he's also inherited the AI of his mom. The next one is RoboSimian. He's one of the upcoming important explobot for space exploration. Actually, he was designed for the rescue missions in hard terrains and hard conditions like flood, landslide, and also the issues related to the melting of ice in the regions like Antarctica. He was really actually designed for that kind of needs. He can roll like a tire, and he is equipped with his four limbs with a very hard grip. And the crazy or amazing factor is he can slide with his belly like a penguin. Just like Iceworm, this is also designed for exploring the icy moons like Saturn's, Enceladus, etc. Then the Valkyrie, looking handsome, right? Okay, in structure and basic functions, he or she is really an astrobot. Valkyrie is designed to help or repair the human-made environments like ISS and our upcoming Luna Gateway mission, etc. He will assist us in the missions like Dear Moon of SpaceX and Artemis of NASA. Just like RoboSimian, Valkyrie was also designed to take the charge of rescue missions, but the space exploration field just adopted him or her. So that's all. I think this is the correct time to stop my small presentation. The history of space robotics was bright. Present is very bright. Then the future will be extremely bright. So let us hope for the great development of humanity through science and technology. And if you want to contact me, you can contact me through this email ID. You can see this.
Apologies for not switch on this camera because unfortunately there are some instability in the network. I'm sorry for that.
No issue. No issue.
In this presentation, I would like to convince you.
Yeah, no issue. It's a problem.
Yeah. Here I'm trying to convince that everyone knows that 4 centuries ago, the great Galileo Galilei made a pioneer observation with his telescope, and it had changed our perceptions of the heavenly bodies. So today I will try to convince you that there is another revolution is happened in the astronomy, and we are in the midst of another golden era in astronomy with the advent of the space. The advent of the space age has opened.
What are you studying now?
I'm an integrated mathematics student, sir, Pondicherry University.
Okay.
The advent of space age has opened very much of new windows to us, and it has opened many windows to the universe, and it has resulted in spectacular discoveries and unprecedented progress in the understanding of these natural celestial bodies. And at the same time, there are many problems and outstanding questions are emerged from our quest for these things. So I will just go into firstly, I will try to convince you there is a significance of space science or space technology in exploring these astrophysics subjects. We know that almost every observations we are making before the space era was based on these telescopes. But here is a problem. When we are making telescopes bigger and bigger, we can gather more and more light and more information, and we can make better picture of the universe. But there is a limitation. The limitation is due to our existence itself. It is very connected to our existence. The limitation is this atmosphere of Earth. The Earth's atmosphere will act like many different density layers, and when light passes through it, it will scatter many times and it will go through multiple refractions, and it will lost many of these information which is coming from far away stars and galaxies. So if you want to look deeper into space and longer into time, you can't ponder that much because our atmosphere will limit our ability to look deeper and longer to the time. So is there any solutions to this limitation? Yes, there are some solutions, and we are making the solutions in these telescopes. That is called adaptive optics. If you can change these especially these telescopes are using mirrors, not lenses. These big telescopes are always Newtonian telescopes. So we can make arrangements in these mirrors, little bit arrangements. It itself is limited to some levels, but for low angular resolution, we can make some arrangement. It is called adaptive optics. You can use adaptive optics, and big telescopes like these ones in Chile, these big telescopes are using adaptive optics, but it's also limited and it's very costly. If you want higher resolution pictures, you can't do this. Is there any solution to this? Our eye to the sky is this telescope. Now we are looking from the sky. We have our eyes in the sky. In 1990, NASA had launched the Hubble Space Telescope. Actually, there are very many stories about Hubble Space Telescope, and I would like to share one story, which is Hubble Space Telescope is launched in 1990, and Hubble Space Telescope sent some photographs of some distant galaxies, and some stars. But these photographs were so much problematic because there are some problem with the mirror of Hubble Space Telescope. That time, the Time magazine had made these Hubble Space Telescopes picture as the cover photo, and they wrote that a billion blunder because these telescope delivered nothing it is sent for. But after one repair, they had done 5 repairs for this Hubble Space Telescope itself using this space shuttle and all. But after the first repair, Hubble Space Telescope sent spectacular pictures, and then the Time magazine wrote one more about the Hubble Space Telescope with Hubble Space Telescope as the cover photo, and they wrote that a billion wonder. So a billion blunder is changed to a billion wonder. Actually, Hubble Space Telescope itself is a big wonder. Since it's 1990, its launch, Hubble was changed our fundamental understanding of the universe. The pictures are astonishing and same time so staggering, so that sometimes the scientists say that it is so staggering such as the imagination even recoils from contemplating something from these pictures. After a long service of 3 decades, this Hubble Space Telescope is going to retire from the sky. There are many telescopes sent after Hubble Space Telescope. There are many of these space telescopes are doing great job and making our understanding bigger and better. But there is also one problem. Hubble Space Telescope is exposed to visible range of radiation. You know that some of you may know that there is a range of radiation that is called electromagnetic radiation. From 1960 onwards, our astrophysics, astronomy, especially astrophysics, is like a jigsaw puzzle. That is, in a jigsaw puzzle, you will get small pieces, and you will fix these pieces in the right order, and you will get a great picture of these details. Our astrophysics is also like this. You will understand the structure of the celestial objects, the stability, its compositions, its physical conditions, and radiation mechanism. Everything is a piece of a jigsaw puzzle. If you know everything of these things, every bit of these details, you can make this jigsaw puzzle to a good picture about the celestial objects. But there is a limitation. So these informations can be gathered using different electromagnetic waves. They have different wavelengths. So there are infrared region where if you are taking a photograph using this infrared, you can get the temperature distribution of this material. So if you are looking the space in infrared radiation, you can get big details about how this temperature is distributed, what's the temperature of that system and all. If you are looking in X-ray, you can understand many things, especially in high energy astrophysics, in black holes or supernova remnants or these things. You can understand more about the spectrum. If you want to study the composition of the supernova remnants, you want to look at the X-ray radiation and the spectrum of X-ray spectrum of these things. And in very high energy astrophysics, especially in galactic nuclei, all these things, you want to look in gamma rays. But we already talked about these things that Earth's atmosphere will prohibit, or some of these are very dangerous rays. If X-rays and gamma rays, they will cause problems to our cells. So they are very dangerous. We are protected by the atmosphere. At the same time, it's a limitation for astrophysics. So they use space telescopes. In the case of microwaves, there is some remnants that are leftovers of this Big Bang. We consider it as evidence of Big Bang. If you are studying this evidence of the Big Bang, if you are familiar with the cosmology, you can know that the universe, we say that the universe is homogeneous and isotropic. That is, if you look anywhere in the universe in a large scale, not in a small scale, it looks same. Any angle, any direction, that looks same. But there are some small anisotropy is there. If you want to study this anisotropy, if you study this anisotropy, you can understand that the fluctuations that's happened in the time of inflation, that's one of the early stages in the universe. So if you want to understand the structure, which Shreya is already talking about the universe. So if you want to understand the large scale structure of the universe, you want to look at these anisotropies in these fluctuations happen in the early universe. There are some early remnants that's left off in the universe that's called cosmic microwave background. So if you're looking these things in a microwave range, you can understand how this distribution of these things. And we have many satellites that's planned for this. The first one was COBE, Cosmic Observatory, and that thing. The second one was WMAP. This is a plot which is made by WMAP, which is looking all around the universe. The other one is Planck. That was the latest one, and they had made great contributions to our understanding in the cosmology. Then comes infrared. If you want to understand these things, the temperature, how the star, if you're looking at the nebulae and if you want to understand how the stars are forming, the visible light is restricted because nebulae contains many of these dust particles and many other particles. So if a star is forming inside it, you can't look inside it using visible light. So if you want to ponder inside the nebulae, you want to use infrared. So it's a picture of this Spitzer space telescope. It's an infrared telescope. So infrared, we have many of these space-based infrared telescopes, but if you can't use these infrared telescopes in infrared spectroscopy, mainly in land-based. There are X-ray. X-ray is very fascinating. This is one of the very major X-ray telescope. It's named after an honor of one of the greatest Indian astrophysicists ever lived. It's named after the Subramaniam Chandrasekhar. It's called Chandra Space Telescope. It's launched by NASA, and it had made tremendous, innumerable discoveries about the black holes, these supernova remnants, high energy astrophysics things. These are very difficult. Making X-ray telescope in space itself is very difficult. So in ground, it is not possible because the atmosphere will not allow X-ray to pass to ground. So we had made a very good observatory in the space, and we are using very much of data to understand how the high energy scales, how the universe works in high energy scale. There are very exotic conditions. If you are looking at a neutron star or neutron stars in binaries, or if you are looking at supernova remnants or black holes, we know that it's already very fascinating. Most of you had heard about it. But if you want to study these things, they are very high energy physics. If you want to study all these astrophysics, there you want to use spectrums in X-rays and all these things. This very successful telescope, it's called Chandra Space Telescope. Now comes gamma ray. We may be bit unfamiliar about the gamma ray, but it's used in our familiarity, it's used for cancer treatment and all these things. It's very high energy. It's very difficult to handle. If it's passed through our body, it will destroy our cells. It will destroy biological cells. So Earth is protecting us from these gamma rays. But if you are ready to accept these gamma rays, and if you can study about them, they also reveals many fascinating properties. If you want to look at a galaxy and study about the center of the galaxy and galactic nuclei and all these things, they reveal their character in gamma rays because they are very highly energetic, more energetic than X-ray. So this is very fascinating area of research. There is a very huge amount of research is happening there. There are much more sensitive telescopes have going to launch, and many more are there in the pipeline. And this is undoubtedly an era of exploring the universe from outer space, and we are going to understand many of the things. We know that we know very little about the universe. That is the very good thing. I think it's a very good thing because we know only 4% of the things in the universe. Else is 25% is dark matter and 17% is dark energy. We want to study about all these things. So it should be an era which is based on space-based astrophysical era. And there are many more things, fascinating things are happening in the space. For example, Kepler Space Telescope is looking for the planets around other stars, the habitable zones, and all these things. Possible forms of life can be there, and there can be aliens, and one day they may communicate with us. So if you want to find aliens, you want to go to space and look at the very detailed observations using Kepler, something like Kepler Space Telescope, because they are using very, very sophisticated technologies. The Kepler Space Telescope is using a technology when a planet is going between the Kepler Space Telescope and the star or in front of the star, it will dim the light. But you are looking very far, light years and light years away, this star and this planetary system, the dim of the light can be very negligible. So if you want to understand these things, these technologies should be so sophisticated, so you can't handle these things in Earth, but you can handle these things in space. The last but not the least is about our own, one of our own space telescope. We know that whenever ISRO is doing something, they did it in a unique way, and they did something special. Most of the time they did something first in India that can be the first in the world. This is the case of AstraSat also. This is the first multi-wavelength space telescope ever launched. Because these telescope, it's a space-based telescope. The space telescopes looks in X-ray, in UV, and many of these things. And it's very useful in study, because the UV part I just neglected it because it's not a very much explored area. But it's very useful when it comes to the vibrational spectrum of specific molecules in interstellar medium and all that things. You can go to the database of AstroSat and look at the data, and you will get fascinated, because it's a very multi-wavelength space telescope. You can look at these things in different wavelengths and understand these things. So we said that from 1960, it's a jigsaw puzzle. Astrophysics is a jigsaw puzzle. Before that, our perspective is that collect more light and collect more data, and we will understand the universe. Now it is like from 2015 onwards, it's a multi-messenger astronomy. That is, gravitational waves is there, neutrino is there. So gravitational waves also using space, because in the Earth it is limited. They are also going to use the space-based systems. And future, we are going to make three-dimensional picture of these celestial bodies, because three-dimensional picture may reveal something more to us. It's possible if you have telescopes that are farther apart and you take photos from two different angles, you can make a three-dimensional picture of these bodies. And we are going to launch, this one is going to launch, it's in the pipeline, James Webb Space Telescope. It's a very big project, it's a $1 billion project. So these things are going to come, and it will be very fascinating era. It will be a very fascinating era to view, and we will be in a midst of a golden era in astrophysics, and we will understand many more things that's unknown to us for many centuries will come revealed in front of us in the next few years. We'll expect that will happen, and it's been a very great fun to be here. It's been very fascinating to see to the folks, they talked before me had done great things, and I salute all the organizers for conducting such a great program. Thank you.
क्या बोलना है?
My name is Shanti Rathod. Study class 1A. My school name is Namakya School, Noida. And I'm so excited to talk about universe. We are very small part of it. There are so many stars around us. Are there aliens too? The color of earth is blue and green. Why Mars color is red? To learn more. Thank you. Bye.
Thank you.
Thank you very much, Shanvi.
Thank you, Shanvi. Thank you very much. You made a good presentation. Keep it up.
Okay. बोलिए.
Color is sentimentally bad, but every blackboard makes students' life bright. Well said by Dr. APJ Abdul Kalam. I would like to dedicate my presentation to the ones who use blackboards and make the students' life bright. Good afternoon to all. Let me introduce myself first. I am Mahi Purohit, studying in class 2 at the Auxilium Convent High School, Vadodara. I love space and I want to be an astronaut in future. I also learn karate and I am a white belt. I have participated in elocution competition and also have delivered Thanksgiving speech at an online event. So let's begin with presentation. I am going to talk about space phenomena. So the space phenomena are naturally occurring events caused by the vacuum of space, or directly result from an event within space. Please have a look at some types of space phenomena are asteroid, black hole, comet, dark matter, exoplanet, galaxy, nebula, planet, pulsar, solar wind star, and supernova. We will see each space phenomenon one by one, starting with first, asteroid. They are different types of rocks in space. A belt of asteroids which divides solar system into terrestrial and gaseous planets is present between Mars and Jupiter. Now next one is black hole, a large massive star that has no fuel and collapsed itself. The core is so densely packed that light and other objects cannot escape its gravitational pull. Now next one is comet. It is a bright heavenly body that develops a cloudy tail as it moves closer to the sun in its orbit. Now next one is dark matter. It is made up of small particles that keep the stars and galaxies moving and can be filled stars. Now next one is exoplanet. An exoplanet is a planet outside the solar system. Many have been discovered. Now next one is galaxies. They are very large group of stars and other matter that are found throughout the universe. They come in different shapes. Now next one is nebula. It is cloud of gas and dust in outer space. It is visible in the night sky as its bright patch. Now next one is planet. There are many unique bodies other than a comet, asteroid or satellite that travels in orbit around the sun. Now next one is pulsar. They are the extremely dense stars that rotate extremely fast. They emit beams of light. Now next one is solar wind. The solar wind is a stream of charged particles released from the upper atmosphere of the sun called the corona. Now next one is stars are huge glowing balls of gases. The closest star to the earth is the sun. Most of the light that shine in the night sky are also stars. Last one is supernova. It is the explosion of very large star. With this, I end my presentation. Thank you for listening to me. Thank you.
A very good afternoon to all of you. Today, I would like to discuss about the Dyson Sphere, a space structure which has only been utilized in sci-fi movies as the human fascination. But I would like to discuss about the possibilities of this hypothetical concept as a reality somewhere in the future. Before we discuss about the Dyson Sphere, we need to understand the current scenario first. The global demand for energy is increasing every day. Reasons are many. Increasing population, technological advancements, exhausting non-renewable sources of energy like coal, minerals, etc. This makes it inevitable for us to look up to renewable sources of energy, and the most important source is solar energy. But according to Nikolai Kordashev, we will be able to tap the entire energy of our planet in the next 100 to 200 years. But what next? A further expansion of need for energy. The most feasible solution the most feasible solution is to utilize spatial solar energy. One such idea was proposed by Freeman Dyson in the year 1960. The Dyson sphere. The Dyson sphere is a hypothetical megastructure that completely encompasses a star and captures a large percentage of its energy. Some other variations suggested were the Dyson ring, the Dyson swarm, the Dyson bubble, and the Dyson shell. The most feasible structure seems to be the Dyson swarm. For a Dyson swarm, a constellation of man-made satellites, each having solar panels, will be installed in an orbit around the sun, just like the solar panels will absorb the sun's energy and transmit it back to Earth. Currently, only 1/1000th of the sun's energy reaches Earth, and the rest is lost in space. If through a Dyson swarm we are able to trap even a millionth of solar energy in 1 second, we will harness the energy equivalent to total power consumption in 1 year. Though the sun will get slightly eclipsed every time the swarm will cross the path between the sun and Earth. But there will be many challenges in the realization of the concept of Dyson swarm. Such a large scale production of satellites in order to tap desired amounts of energy will be the biggest challenge. Earth may not even have enough minerals to build the satellite.
Yes, sir.
If somehow
कर दिया सर, पैनल में भी लाया था, वो बाद बीच में आउट हो गया होगा, भी कर दिया दोबारा, आगे.
if we somehow build these satellites, having them near the sun in such a close orbit will be very difficult. The swarm may temporarily block the sun, creating an eclipse every time it crosses the Earth. Transmission of the energy to Earth will be another difficult task. There will always be a risk of collision of the satellites with the sun, some asteroid, or other heavenly body, or even amongst themselves, creating a spatial debris and also affecting the efficiency of the structure. To conclude, I would like to say today the concept of Dyson sphere looks completely unattainable and only good enough for sci-fi movies. But there will be one day in future where we will look outwards our planet for energy. So we need to do more research on it, and I wish to do this research when I grow up. Thank you.
Good afternoon. I am Dikshit Satyanarayana from Erode, Tamil Nadu. I am going to tell a story about life in space. Story time. It's story time from space. He is Vicky. I am going to introduce two characters of my story. He is Vicky and he is Rocky. New things are always special to us. We humans would love to make the space as our home. As a result, ISRO made a big rocket and it took 1 year to complete the project. On the day of launch, Vicky and Rocky were there in the launch vehicle. Now the launch initiated. 3, 2, 1, launch. Rocket went to moon. They landed on the moon and their mission was to make moon their new habitat. Few hours later, their first need for food arises. They had food from their vehicle. Rocky thought that we should plant some plants. For that, we need a cup of soil, told Rocky. Yeah, we can use human waste as soil. Vicky had a sprouted potato. Suddenly, an idea sparked in his mind. As the sapling needs sunlight, so Rocky made a circuit box with human waste. They communicated to ISRO station and said that we need food and seeds through next batch. They received all that they need growing crops in moon. Many experiments were futile. At last, they end up with devising an artificial sun, moon, rain, clouds, and etc. Hence, they achieved their mission. But we have our new planet Moon, but we should not pollute like
So, very pleasant afternoon, everyone present here. My name is Shubhani Mathur, and today I am going to talk about commercialization in space. So, recently, as we all must know, Jeff Bezos, the founder of Amazon, along with 3 others, made a space trip, giving a start to space tourism. Tesla's CEO Elon Musk is already building spacecrafts that would run like space lines, just as airlines, to the upcoming tourist destination, the moon. Once the space tourism becomes popular, space hardware will become the most sought after items that would be sold on e-commerce portals. Space hardware will not only include parts of rocket, but also items related to colorful parts of spacesuits, beautiful helmets and shoes, fancy oxygen cylinders, packaged foods, and many more. Scientists have found that uranium is so abundant in space that its minings can end the power wars on entire Earth for a million of years. Hence, they are exploring options to mine such minerals on various planets and asteroids. Antriksh Corporation and New Space India Limited are the companies set up by ISRO for sale of space technology and hardware. Similarly, a number of private companies like SpaceX, Blue Origin, and many more are created for the purpose of commercialization in space technology and the space itself. While the commercialization of space is a new frontier of human development, but before every step we are going to take, we must be mindful of the environmental impact of our activities in space. Thank you.
न चोरहार्यं न च राजहार्यं न भ्रातृभाज्यं न च भारकारी व्यये कृते वर्धते एव नित्यं विद्याधनं सर्वधनप्रधानम्. India, the cradle for the first civilizations, gave rise to millions of scriptures and Vedic texts written profoundly in Sanskrit. But are these as straightforward as they seem to be? Or are there any hidden codes or hints in them? Hello and namaste everyone. Myself Agrahya Rathore, and today we will together decode the secrets of Indian astronomy through the ages. But before starting, I would like to thank Sri V.K. Jain sir and ISIE for giving me the opportunity to present at this very informative workshop. So let's jump right in. Indian astronomical discoveries date back to as early as the Indus Valley civilization. At that time, the information was transferred from generation to generation by Shruti and Smriti Parampara. Shrutis were revelations through experience and knowledge of the rishis, like the 4 Vedas, namely Atharva Ved, Samved, Yajurved, and Rigved. And Smriti, which literally means to remember, and because the information was too much to remember, these were converted into hymns and shlokas. Talk about instant learning methods. One example of it is the Surya Siddhant, or the earliest text on Indian astronomy. One such shlok, which is Tatha cha samaryate yojananam sahasram dve dveshate dveja yojane ekena nimisharthe na kramaman namostute, was quoted by an important Vedic scholar, Sayana, in the 14th century from this book. Surprisingly, it calculates the speed of light, which is very close to the modern calculation. Let's try it ourselves. The present value of 1 yojan is equal to 9 miles approximately. and 1 nimish is 16/75th of a second. Then half nimish will equal to 8/75th of a second. Substituting the values in the formula, we get 1,85,793.75 miles, which is very close to the present value, which is 1,86282 miles. And this book existed thousands of years ago. It also considers Earth as a sphere and not flat. Later, in the 5th century, a Vedic genius Aryabhat wrote a treatise, Aryabhatiya. Among the many surprising discoveries mentioned in these manuscripts, this is the one which explains eclipses. Here, he symbolizes moon as water and sun as fire. According to him, moon obstructs the light of sun just like water obstructs and extinguishes fire. Similarly, shadow of earth obstructs moon, which we call solar and lunar eclipse. He also claimed that the sun remains stationary, but the earth rotates about its axis. You may recall that the name of the India's first satellite is given in his honor. Yuga Sahasra Yojan Parabhanu Lilyotahi Madhur Paljanu. You may have heard this verse in the Hanuman Chalisa written by Tulsidas in the 16th century. Turns out, this too calculates the distance between sun and the earth. As Hanuman is praised by saying that he almost swallowed the sun, which was at a distance of 12,000 divine years, which is 1 yuga, in 1,000 yojana, thinking it to be a sweet fruit. Substituting the values, we get distance between the sun and earth as 160,934,400 kilometers. Now, just look at the current value. Now, next. Now, I'm sure most of you would have heard about the Mahakumbh, celebrated at Prayagraj in every 12 years. What if I tell you that it is based upon Brihaspati or Jupiter's cycle? It is recent discovery that Jupiter completes one cycle around the sun in 12 years. The gravity of Jupiter keeps most asteroids and space rocks away from the Earth. Without it, Earth would most likely be inhabitable for humans. It is being celebrated since thousands of years, and Brihaspati is worshipped as Guru. Last but not at all the least, we come to ISRO, the pride of our country. Mere words are very less to describe it. ISRO has really reached the pinnacle of success, thanks to the determination and hard work of our brilliant scientists. People like them are the real heroes and inspirations for the young generation. Astonishingly, all of these amazing discoveries done by our genius ancestors that made their way into this presentation are just the tip of the iceberg. The rest is yet to be explored. I hope you enjoyed the presentation. It was an honor to present today in front of all of the wonderful scientists and the diverse audience. Thank you and have a wonderful day ahead.
Good evening to everybody present here. This is Mr. Hudson of GD, waiting in front of you to explain what are artificial satellites. First of all, a satellite is a machine made by humans which is launched into space, to orbit a heavenly body. India has launched over 352 satellites for the last 50 years. From the first satellite Aryabhatta to GSAT-31, we have made amazing ventures. These are the 4 famous satellites by India. There are 9 different types of satellites that let us see in detail. Let us see them in detail. Communication satellites. Satellites which help in communication using radio waves is known as communication satellites.
Lalit, relax, and slowly you can tell.
Relax करके आराम से बोलो बेटा. कोई जल्दी हड़बड़ाहट मत करो. Take your time.
हाँ जी. As you see in the picture, this explains how a communication is transferred to satellite in the binary number zeros and one, and then decoded from the satellite to the receiver of Earth. Remote sensing. This is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at distance. As seen in the picture, the sun radiates the object, and this emission is then reflected to the satellite. ground satellite, a satellite network that operates around the world for transmission of short messages between aircraft and ground station is known as a ground satellite. Polar satellites, a satellite which is designed to exhibit the poles of the heavenly body is known as polar satellite. Navigation satellites, a satellite designed to enable the operators of vehicles to determine the geographical positions. This is done by the navigation satellites. Orbits of satellites. An orbit is like a track in which planets or satellites move. Low elliptical orbit. As you see in the picture, the orange line denotes a low elliptical orbit, and this is around 500 to 1,500 kilometers from the Earth's surface. Medium Earth orbit. It is from this. As you see in the red line, this is medium Earth orbit, and this is at the altitude of 8,000 to 18,000 kilometers. Geostationary equatorial orbit. This equatorial orbit is at the altitude of 35,785 kilometers. High elliptical orbit. A satellite orbit that is higher than the Earth orbit, that is more than 35,785 kilometers, is known as high elliptical orbit. A global positioning orbit is in which global navigation satellites is fixed. This helps you get where you're going from point A to point B. Okay, let's see in an animation in which our Indian satellites move. Use of satellites: television, cable and network, telephones, navigation, business and finance like banking, weather, climate and environment monitoring, safety. Presently, even on online classes. Conclusion: simply, life is nomadic without satellites. Thank you.